Hello, Mr. Harry, Mr. Ryan, are you right?
No.
Are you right? Okay, so we're given a string with all uppercase letters. So for example, like A, C, B, D, A, B, B, C, C, D, D, okay? All uppercase letters. And we can remove all the occurrence of A, B, or C, D, right? So we want to find out the minimum length after removing as many A, B's or C, D's. So we're given a string of all uppercase letters. We want to remove one operation. We can remove A, B, and C, D's from the strings, and we want to find out the strings after removals.
What ABs?
A, B's, you know, if you find A, B's here. So do you find A, B here?
4.
What do you mean 4?
Answer.
What do you
can
mean
take only
AB?
four.
You can take
AB.
A, B, this is a substring. So we want to.
A, B, C, D, C.
Yes, look, you remove these two, and then you can continue remove these two. You can continue remove these two, and you can continue remove and 4. Yes. Okay, that's the answer. Correct. This is the minimum length after removing A, B, or C, D.
Yeah.
Okay, so another example. A, B, C, D, A, B, B. Okay, what's the answer? What's the answer? What's the length after removing the A, B's or C, D's?
3?
3?
No, 1. Right?
Okay, that's
One.
right. So how do we do it? Removing this, removing
Yeah,
this,
1.
removing this,
AB at the beginning.
remove this, yes, A. Okay, that one. Okay, seems a easy question. What's the strategy to do this? How do you know it's 1? Ryan, how do you know this is 4?
I counted
How? I
in
mean,
my brain. Yeah.
given a string, how would you do it?
Force.
Brute force, yes. And how do we brute force?
We check every number, every A's and B's and C's and D's.
We check for the existence of A, B, and C, D, right? And then we remove it, right? As long as they're still there, right? Look.
Is it possible
Mm-hmm.
you can do this like window thing, and then like if it's A, B or C, D, you delete that and then check if it's still A, B.
Yes, quite close,
For
yes.
example, and then
This is my optimal solution. I was going to talk about the stupid, brute force solution, and then talk about the optimization, yeah?
So you have this window.
Yeah.
That's not C.
Yeah.
No.
Uh-huh.
B, D,
Yes,
no.
yeah,
D, A, no.
yes.
A, no.
A, B?
A, B, yes.
Yeah, uh-huh.
We delete that and then we get
Yeah.
I don't know.
Yeah, it's quite close, yes. The window, but it's not necessarily the window. It's more like checking the next character and the previous character, okay? You can think of it as a window of 2. Okay, so let's go for this brute force way first. Okay, so how do we brute force? This is the mean length after removal, S, right? So how do we brute force? So we just check, right? Why AB is in S or CD is in S, right? We use the in. So why we still have AB or CD in the string, right? If we have AB, if I'm telling you there is AB and or CD in the string, so what do we do with it? So I'm telling you, okay, this
Delete it.
delete it. Yes, we delete it. How do we delete it? It seems a stupid question, right? Yeah. So when we find AB, when that string AB is still in the S or CD is still in the S, so we remove it. So we can use the replace function, right? So S equals S dot replace. Replace AB. This is one way of removing a substring, okay? So it's the most intuitive way. Replace AB to empty string, and S equals S dot replace. What's replace? What is the meaning of replace? Replace CD to empty string. And that's it, look. S equals S dot replace AB. Replace, you want to replace AB to empty string. What does it mean? What does it mean by replacing AB to empty string? What does it mean?
It's basically just replacing it with nothing.
Replacing with nothing, what does it mean?
So Just deleting it.
Yeah, deleting it, yes. Replacing AB with nothing is basically deleting it. So we're doing two things, right? Replace AB to nothing and replace CD to nothing. And we can merge these two, right? Look, S equals S dot replace. We can actually put these in at the back. S dot replace AB to nothing dot replace CD to nothing. So the problem with this one is that the replace function takes O(n) time because it needs to look for the substring and then to replace it. And not to mention that the string in Python is immutable, right? Immutable. So we can't actually modify the original string. So what happens is that we create another copy of string and replace it. So this actually creates a copy because, as we know, right, strings in Python is immutable. Immutable means that it's not changed. We are not modifying the original string. We are actually creating a new copy and then replace it and assign it back to the S, right? So this is quite inefficient. Inefficient. It's not very efficient in terms of time and space. Okay, in terms of time and space. But this also works. The time complexity in here you can think of as a quadratic O(n) squared because in the worst case, what's the worst case? Worst case is
Does it
have
to be capitals?
Yeah, and then B, right? So, right, this is the extreme cases. So, what happened here? Yeah, AB here in the middle. So you do this, right? When we have AB, we find this AB, we remove it.
You just count how much A is.
And then remove it. So every time we need to do this n times. Do this n. This is half n, right? N times. And every time we need to replace it. Allocating a new string.
How do you know if the amount of A's and the amount of B's are the same?
It doesn't matter. I'm just saying that we have enough B's to.
Because there's one more B than there.
Yeah, I know.
So that means you delete the amount of A's.
And but the thing is that this one while loop at the beginning only one AB. Why? It only finds one ABs or CD, AB or CD, right? And then it needs to replace that with empty string. After replace, we have another AB. Okay? No. You are quite close at the beginning of the window thing. So how do we do this? Look, we just go here, right? We just go through A. So if it's B, if we reach the B, we check the previous character to see if it's A. If it reaches the D, we check the previous character if it's C. Right? If it's B, the previous character is A, then we remove it. And then we go next. If the previous character plus the current character is A, B, or C, D, then we remove the previous one. So how do we remove it? We can keep using a stack, right? So how do we do this? Look.
Oh yeah.
Okay, so we can use the stack. What's stack? First in, last out, right?
Yeah.
Look. A, B. How do we use the stack? We are using a stack, right? Yeah. So look, A. Okay, let's put another B here. Okay. If it's B, we check if the stack is empty. If it's not empty, then we check if the character is A. Okay. So in this case, we just put a B here. We put a B here. Okay. We put an A here. Okay, we put an A, and okay, now it's B, right? Look, it's B. What happened? The top of the stack is A. So instead of putting it, we just remove it. Okay, here B. Now we take one more A. B, A. Okay, so now the remaining 2, right? 2. So is it 2? Look, 1, 2, 3, 4, 2. Makes sense. Let's consider another example with CD. A, C, B, D, A, B, C, C, D, A, B. Okay? This example.
Yes.
At the beginning, stack. So A, right? We remove the top of the stack if the character concatenate the current character is A, B, or C, D. So now A, current character is C. So we put it there. B. Do we remove this C or no? No, because it's not A, right? If we can't remove it, we put it B here. D, can we remove this B? No, we put it there. A, we put it there. Okay, B, can we remove this A? Yeah. And then we don't put it back, right? And then now C. No, right? We put it there. C, we put it there. D, can we remove the C?
Yeah.
Okay, and A, can we remove the A?
Yes.
Yeah. Okay, so what's left? C, D, B, C, A. So 5. Okay. Yeah, makes sense. Is it similar to your window thing? Is it similar to your window thing?
Yeah, sort of.
Yeah, sort of. Okay, so let's do the code and let's. I need the eraser.
Use my sock.
No. Okay. So we need to maintain a stack, right? Need to maintain a stack. Define the mean length. Stack A equal empty. We can use the list as a stack. So for I in S, if A is not empty, right? If we have at least one element in the stack. If A is not empty, and we can do this, A minus 1 is the top of the stack, plus I, if it's in A, B, or C, D, right? The previous stack, the one on the stack, plus the current character, if it's A, B, or in the C, D, then we need to pop it, right? A dot pop. We can remove it from the stack, right? Otherwise we need to put it on the top of the stack, right? So we append it to the stack. At the end, we return the length of the A. Okay, so to sum up, when can we remove the top element of the stack?
When the bottom one is the letter before in the alphabet.
No, but then you can pair up B with C.
Yeah. So basically, if the stack is not empty, then we take
Can
it.
you pair up C and B?
No.
No, look. So this is the top of stack plus the current character, and if it's A, B, or C, D. So basically, if this previous one is A, B, or C, D, the previous character is A or C, and current character is B or D. If it is, then we need to remove it. Otherwise, we just append it to the stack, and then at the end we return the length of the stack. The time complexity here is what's the ON? Yes, we're going through, right? Look, we're going through, right? The space complexity is
O1, O-N.
ON because we're using a stack. The previous one, the space complexity is ON as well. The time complexity is ON squared.
These capital letters, well, they don't have to be capitals because capitals don't really matter.
Yeah, okay. What have you learned? And
we need to remove the A's, B's, and C's to find the minimum length of the substring and the string.
how many solutions have we talked about, Eric? Ryan?
We talked about 3.
Okay, what are those two?
Stack
How do
and replace.
Yeah, stack.
we- Okay, so can you tell me what's this? Can you explain to me what's this solution? How do we work it out here?
Is it stacky?
Yes. How do we solve this problem using a stack? Can you
We
explain to me?
basically push the first one and
Yeah.
then push the next one.
Yeah.
And then check if we can remove
Yeah.
the bottom one. And then we
Yeah.
go to the next one and go to the next one. And then so basically we put in the first letter in and then the second letter in and check if it is exactly one space after. And then it will be otherwise you will keep on going. And then B and then check and then so on. And until you go check like the A and B, the first one, you remove the bottom one. Replace them with nothing. Hedgehog.
Stack. We just put the elements and the letters in this thing, stack thing, and then if 2 matches, they have to be in a certain order. They match. It's just like the DNA thing. But it has to be one order. If, for example, it can be A, B, but not B, A. So, yeah, that's what we do it.
We go through these letters in a string, right? And we check.
It
We
does-
only no. We're not pushing it every time. We only push it to the stack if it does not form A, B, or C, D with the previous character.
It's what I said. It's what I said, because if you put the first element in, you've got nothing to
Yeah.
the previous. Yes, so that's what I'm saying.
Okay, and then the next
And
character.
it's like seeing for the second one you do match and so on, so on, and so on.
What's the second characters? From the second character, what happened?
You check. I already said it.
We check what?
If it match.
Okay, if match with
Yeah,
ABC.
I already talked about it.
Okay.
Yeah,
What's the time complexity?
You just like you have your own language.
Okay. My own. Okay, what's the time and space
You don't
complexity?
really understand.
What's the time and space complexity?
O-N and O-N. You already asked me.
Okay, that's it for today. Bye bye. Bye bye.
Bye!